Okay, in this example, we're going to do something a little bit new. We're going to use our rules for derivatives, but we're also going to see how that can get us the equation of a tangent line, and then how to graph that and see that the result is correct. So first of all, let me remind you that on your formula sheet, which I've copied and handed out to everybody, there is sort of a general formula or recipe, if you will, for the equation of a tangent line. And I think a lot of times I've seen people get stuck on these problems, and as soon as I ask them to just write down the general form and tell me what each letter represents, they're less stuck and often not stuck at all. They're like, oh, I just fill it in, and that's exactly right. So let me start with that formula, and I think the best one to use is the kind of modified point slope formula. So this is y equals m x minus x0 plus y0, where x0 and y0 are given x and y values, and of course m is the slope. So x0 is usually given, and it is in this problem exactly. It's x equals 5. y0 should be the corresponding y value, and so that's the y value at, in this case, x0, but that's 5. And so we find that by just plugging in 5 to the formula. And then so far we haven't done anything new. M is the new part, meaning that's what we can do now that we know some calculus. And this will be f prime of x0. And so in this case that's f prime of 5. And again, just like in the previous example, when I write that notation, it always means do the derivative first and then plug in 5. And you cannot do it in the other order. And you also can't forget to plug in 5. Okay, so anyway, x0 is given. Good. Let's calculate y0. So that would be f of 5. And so that's 2 times 5 squared minus 5 plus 3. So that's 50 minus 2, 48. Okay. And again, the most interesting part for us, the derivatives, or not derivatives, just the derivative. So I'm going to bring the power down in front. So there was a square. I bring it down in front. This is 2 times 2x to the 1 minus 1 times x to the 0 plus 0. This is 4x minus 1. Okay, and so m is f prime of 5. So that's 4 times 5 minus 1, which is 19. And now I can just plug all of this information in to my point slope form of the line. I guess I didn't circle the 5 up above in red. I'll do that. Just plug those 3 numbers in and you're done with the first part. So y equals 48, x minus 5 plus 19. Oops. You guys see what I did? All my calculations were correct, but I do need to pay closer attention to the formula and which thing goes where. So y0, that was positive 48. Where is that supposed to go? Ah, that's the number at the end. And m, that was 19. Where is that supposed to go? That's supposed to be the number in front of the x's and stuff. Okay, well, easy come, easy go. So let me rewrite this. Y equals 19, x minus 5 plus 48. So that's the graph that I will look at in Desmos. Okay, so I've already gone over to Desmos and entered the original function, f of x equals 2x squared minus x plus 3. I've entered the formula for the straight line, but I haven't turned it on yet, so let me turn it on. And you can see it doesn't look very good, honestly. I cannot tell from that at all that I have a good tangent line. So let me think about what's going on. I remember in the point slope equation, 5 represents the x value and 48 represents the y value. And so I should have a window that includes 5 and 48 in the window. So I'll change my window size, and while I'm at it, I think I'll get rid of most of the negative x values. I don't need those, and similarly, I don't need negative y values. So I will change both. So on the x, let me go from 0 to 10, nice round number. And then on the y, let me go from 0 to something bigger than 48. How about 90? Okay. So what I see here is right at the point 5, 48, or as close as I can get to it. I got it exactly. The red graph, which is a curve, looks exactly like the blue graph. They touch at one point and they have the same slope, and in fact if I zoomed in more I wouldn't even be able to tell them apart. That means I have a perfect tangent line. Now I already talked about the x and y value should be 5 and 48. So what's impressive about this is that the slope is correct. The tangent line has slope 19, and we got that using our formula for derivatives. And this kind of proves that we have the right formula for the derivative, at least in this case, and as good as the picture is, sometimes pictures can be off, but if the picture's accurate, this proves that the slope needs to be 19 for that line to be tangent.